Thank you, Cesar. Now, we create the chart with this testing point, -6, 0, and +6. I don't know, I put too long table, but it's okay. The factor involved in my problem is x plus 5, x minus 5, not total. When you plug it in the sign here is negative, the sign here is negative, is positive. 0 is positive, 0 is negative, and 6 is positive. And remember, our inequality is greater than 0. That means the true guy are the positive. This is the true. This is the true. Now you highlight that part from 5 to infinity positive, and from -5 or negative infinity to -5. No? Of course, do not include no the endpoint, because we have no equal in this problem. No. So the final answer is from negative infinity to -5. Union or gets the same 5 to infinity, gets the option B. Okay, the final answer is from negative infinity, comma -5, parenthesis union, or is the same. Okay, 5 to infinity. End the story. Any question? No. Good. We are the best, Jasmine. Okay. Let's move on to the collection 17, 18, and 19. It's the same thing. Okay, basically is using the factor theorem to determine whether x minus c is a factor of f of x. So you basically, the thing we're doing is you apply synthetic division for all the polynomial using the factor, linear factor x plus 4 in this case, no, or whatever. Entonces f of x is equal x to the third power plus 2x to the second power minus 6 plus 8. You need to prove somehow. I want to explain two different ways. Either way is good. See the factor x plus 4 belong or not to the polynomial. Okay, one way is using synthetic division. Okay, synthetic division. You copy the coefficients, get 1 to -6 and 8. Be careful that they are not missing. Si es missing, you put 0. But one fantastic way is x to the 0, x to the 1, x to the second, x to the third. You see, it's completed. Perfect. Don't forget, okay, now here, the factors, the number you put here is -4. It's completely opposite sign of this. Okay, so you see positive in the factor, and the synthetic division is x minus 4, it's equivalent, no? Actually, when you put equal to 0, and you solve this, it's x equal -4. This is the idea, no? Okay, bring down 1, multiplication, -4, and -2, and -2 multiplication is positive 8, it says 2, and 2 times -4 is -8, 0 remainder. Okay, therefore, you verification using the factor, the famous factor theorem, that the factor x plus 4 belong to the polynomial. End the story. We don't need to continue. No. It's only say yes or no. Another way to do the same thing is, well, you plug it in, no synthetic division. No, I don't like this. Okay, I like personally. But suppose another student or another guy que don't like, you evaluate the function in -4. Because I suppose que si it says 0, the answer should be 0. So -4 to the cubic power plus 2 times -4 to the square power minus 6 times negative 4. Be careful with the sign, plus 8. Okay, this is negative 64. It's obvious it's negative because when the exponent is odd number, it's negative. But when the exponent is even, no, it's positive. Okay, 16 is 32. This is 24, and this is 8. This is your verification. 32, 24, 8 is, let me see, 12, 14, carry that 1, 64. So I add in the positive part is 64 minus S0. Okay, so you can use a calculator either way. What will you prefer, synthetic division or plugging in? Synthetic division, in my opinion, is easier because you normally manipulate, not in this example case, straightforward, but another example a little bit more complicated. So now you manipulate with a big number, see you plugging in. It's the only disadvantage. Okay. Cool. Any question, guys? No? Let's do it quickly because it's the same stupid thing. 18 and 19, no? You have no problem with this or no? Yes or no? No, no problem. Let's do an 18 first. 18, the polynomial is x to the 4th power plus 12 x cubed plus 4 x squared plus 40 x minus 96. And you need to investigate si the factor x minus 12 belong or not to the polynomial. In this case, I want to do using synthetic division. X to the 4, x to the 3rd, x to the 2nd, x to the 1, x to the 0. The coefficients are 1, 12, 4, 40, and negative 96. And the factor is 12 positive, opposite side. Okay. Just bring down 1, multiplication is 12, this is 24. Wow, when you see increasing, stupid increasing, entonces never is 0. But okay, we continue. I multiply 24 times 12 is 388. We combine here is 300 or 200. Is 292. Wow, when you multiply a huge number, 3,000 something, 504. When you add in this number, 3,544. Wow, when you multiply this and this, wow, huge number, 42,528. Can you subtracting 42,432. Remember, no zero. The answer is no. This factor don't belong to this polynomial. Good. Okay, let me do one more. Case 19. Are you getting the number? Well, we using the calculator. I suppose you know the procedure for the synthetic division, huh? Where I come from? So you multiply 1 times 12, 12. This is this 12. You add it, 24. Multiply 24 times 12. Put in the calculator. Is 288. You know that, right? Okay. No. I suppose you know that. Pero si you don't, no, let me know. Okay, let's do a 19. Well, 19 is nice. I like 19. 19 is x to the 6th power. Minus 13. X to the 4th power. Minus 52. X to the 2nd power plus 64. I need to prove somehow that the factor x minus 4 belong or not to this. In this case, be careful because I can see que some terms in this polynomial is missing, no? X to the 6, X to the 5th is missing, X to the 4, no, X to the 3rd is missing, X to the 2nd, X to the 1 is missing also, and X to the 0. Okay, this is 1, missing is 0, minus 13, 0, minus 52, 0, and positive 64. And don't forget change the sign. You divide synthetic with the 4. Bring down 1, multiplication of 4. 0 plus 4 is 4. 4 times 4 is 16. 3 positive. Multiplication is 12. Adding is 12. 12 times 4 is 48. Positive 48. Subtraction is negative 4. And negative 4 times positive 4 is negative 16. And we combine is negative 16. And negative 16 times 4 is negative 64. Wow. I mean, remainder 0, that means this factor belongs to the polynomial. The answer is yes. Any question? I try to illustrate very well in this example. Okay, when you want terms in the polynomial missing, and you perform synthetic division, you put 0. This is important, guys. Sometimes you forgot. Sometimes I forgot. Entonces, I don't understand what happened. What's going on? Because some is missing, I don't consider this item. Okay. Let's continue. Okay, now the rest of the problem 2021, 21, let's see, 22. Basically, that is a problem about the Descartes rule. And the Descartes rule is super easy. Okay, some people, this is the day that some people need to send me a lot of tests and the other class I'm teaching. Okay, don't worry. Let's do in 2021, 22, no? 20, 21, and 22. It's the same thing, super easy, Descartes rule. Descartes rule, give me a prediction about how many positive 0, real positive 0, or real negative 0 of the polynomial. It's a prediction. Okay, suppose the first 20 f of x equal minus 6 x to the 9 power. Wow. Degree 9 means that this polynomial contains 9 solutions, 9 0. But this 9 0 include complex, by the way, the complex is coming by pair of conjugate. And also the multiplicity. You count everything. Okay, for apply the Descartes rule, you don't need to put 0 in the missing guy. No. This is amazing. It's super straightforward. And you study the amount of change of sign. This guy is negative. Now this is positive. One change of sign. This guy is positive. And now the next is negative. One change of sign. And negative positive. Entonces, I see que P, capital P, is equal to 3. Entonces, the interpretation is we have 3 or 1. Where come from that 1? You're subtracting even number. So 3 minus 2 is 1. And 1 minus 2 is negative. Have no sense in negative quantity. Therefore, we have 3 and 1 positive real. 0. What is the value? No. Descartes don't give me information about the value. Now you are doing reflection. Reflection give me the possibility to find the negative real 0. So remember, when you make a reflection, the exponent ought change the sign. This is odd also. And the exponent even no, stay the same. So when you analyze the chain of sign, I can see positive, negative, 1. Negative, negative, no. Negative, positive, yes. The capital N is 2. And 2 minus 2 is 0. And 0 is one possibility. So we have 2 or 0, negative, real, 0. Entonces, ay, guys, I am no good of the selection, in my opinion, is the option D, no? Because the option D say que we have 9. Give it the maximum number of zeros of the polynomial. That depends on the degree. Degree is 9. We have 3 or 1 positive 0 because the capital P is 3, 1. And no comma, 2 or 0 negative 0. In my opinion, the best option is the option D. No? Any question? Do you understand very well this Carter rule? Okay. Let's do one more couple. So one couple of these 21 and 22 to make sure that we understand very well this Carter rule. Okay, 21. 21 is, the polynomial is 8 x to the 8 power minus 4 x to the 7 power plus x to the 6 power minus 4 x plus 8. Let me check in just in case. I could be right, I could be wrong. I could be right, I suppose, yes. Okay, let's analyze the P. P is the number of changing of sign, or the change in sign, and the original polynomial. And the original polynomial. So I can see, for example, positive, negative, 1. Negative, positive, another. Positive, negative, another. Negative, positive, another. In total, we have 4. P is 4. Oh, no, actually, it's not 4. It's 4 is 2 and 0. Remember, you subtracting even number. 4 minus 2 is 2. 2 minus 2 is 0. Is 0 minus 2 is negative? No. Negative have no sense. Now, in order to find the negative part, the only thing you should do is make a reflection. And remember, the even exponent stay the same. However, the odd exponent no change. This stay because it's even. This is change because it's odd. Exponent here is invisible 1. Now, wow, look at that. Never change the sign. Totally flat. Okay, now n is 0. So what is the fantastic conclusion? The fantastic conclusion is, wow, a lot of people annoy me. Option A, no? Option A is, we have in total A0 because the degree of the polynomial is 8. However, we have 4, 2, or 0 positive 0, like a P indicate me, and no negative 0. Option A, I select. So clear? Okay, one more, or you are boring to do this game? It's a game, no? Okay, let's move in 22. Oof, let me erase this. 22. Guys, I suppose everyone follow me, no? Oh, no. So where there are, where there are what? I don't understand the question. What do you say? Vance, what's your question? Activate the microphone if you want. 22. How do you know what number to flip the sign? Okay, good question. Okay, I want to explain in detail now in the 22nd. 22nd, we have x to the 6th power plus 4 x to the 5th power plus 4 again x to the 4th power plus 3 x to the 3rd power minus x squared. Okay, minus x squared minus 5x plus 4. Okay, so everyone understand very well what is the situation of the chain of sign. This is positive, this is positive, this is positive. Wow, it doesn't change, the sign stays the same. We have 1 here, no, and yes. Therefore, P is 2. 2 or 0. That means that our polynomial predict 2 or no, or 0, nothing, positive real. This is the interpretation of P. P indicate me. Now your question, Banks. How do you know when you make a reflection, what is stay the same and what change? The even guys stay the same. The odd guy, like this, or this, change the sign. Do you understand why? Or I need to explain the reason? Make it sense for you or no? Because remember, the reflection, Banks, answer me. Okay. Sean. Who asked the question? One guy gets called Banks Amazing. Are you there or no? No? Okay. Okay. So let can you explain the zero bar? What is the zero bar, Jasmine? Zero bar. Yeah. Got it. Okay. What means yes, Banks? Can you want to explain what is the reason can I change or no change? The zero bar, Jasmine. Better, you made me crazy. The zero bar, Jasmine. Remember, you find P. P is 2. Because I can see using this mnemonic device to indicate 2 chain of sign, and you subtracting 2 minus 2, 2 minus 4, 2 minus 6. So you subtracting even number until P is 2. Yeah. Okay. So everything is everyone is clear or not clear? Sure. The oldest point. It is the old. Yeah. The oldest point. Yeah. Okay. Super. I suppose everyone understand very well, no? Okay. Let's make a reflection. The reflection is this stay the same. This no. This change. This is even stay the same. This is odd change. This is even stay the same. This is odd change. It's odd because it's 1, no? Invisible 1 upon plus 4. Okay, now I can see, look, positive, negative, positive, negative, negative, stay, negative, positive, and positive. 1, 2, 3, and 4. And it's equal 4. And Jasmine, you subtracting even number from 4. 4 minus 2 is 2. 2 minus 2 is 0. 0 minus 2 is negative. And negative have no sense. So we have 4, 2, or 0, negative. Real 0. That was the rule que discovered Descartes of the polynomial. And this is amazing. And give me some information about the amount the possibility, no? So you want to investigate more, you are doing a table. Well, we are using sophisticated tool. We have now Desmos. We have also Wolfram Alpha, no? Mm-hmm. But in the time of the Descartes, we have no computer, no internet, there are no electricity. And they try to working in this algebra. There are no power, no electric power in this time. The electric power was created in the United States and Edison, Edison, Westinghouse, but in the last year of the 19th century. And the full application was in the 20th century, so the last century. Okay. Okay. Entonces, everyone understand very well the scatter rule or no? You are ready to apply that in your Alex homework. Eso, bueno. Alex homework. Okay, let's change the flavor. Let's move on to the listing. This is super easy. Listing the rational zero. Remember the idea for the theorem of the rational potential zero is, suppose we have 23 question, 23 question is, suppose a polynomial like that, 6x to the 4th power plus 3x to the cubic power, minus 4x squared plus 2. And remember the rational, the theorem of the rational, potential rational. The mean potential is because the theorem do not guarantee the existentiousness of this rational. So this is like one clue to start. Suppose we have no Desmos, no? Entonces you investigate, but unfortunately, it's very, very bad. Okay, when you finish, you don't discover the rational is no zero of our polynomial. It's unbelievable. Okay? Entonces, of course, we are doing it in different way in the real life. In the real life, we put in Desmos, and Desmos you see clear the rational, because a rational is a fraction, 3/4, or whole number, 1, -1, 3. Entonces you perform scientific division because you know that this is a zero. And the remainder polynomial maybe you solving, and sometimes quadratic equation using quadratic formula. Entonces you discover another complex or another real irrational that you don't see. You see, but you see in decimal approximation. Okay? This is the idea. Okay, so what is the idea? The idea is plus or minus P over Q. This is the formula. And who is P, who is Q? This is P. And it's a Q. Yeah, I don't care the sign. The sign is not important because it's absolute value. So actually is a fraction. And P is 2. And you put all the factors involved 2. Que is plus or minus 1 and plus or minus 2. So 1 always participate in this game. A 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The shortcut or the mnemonic divide is you multiply like that. 1 times 6 is 6, 2 times 3 is 6. Okay, he always plus or minus. See, I create the list of the potential zero is, for example, I like that way. So you take the first number in the denominator and you create the fraction like that. 1/1, 2/1. So the list is plus or minus 1, plus or minus 2. It was, I take this, divided by the first and the second in the top. Likewise, plus or minus, now 2, 1/2, and 2/2 get 1, but 1/2 here. I don't need to repeat it. Okay? Common. This is 3 now. 1/3, Comma, 2/3, comma, and now 6, 1/6, and 2/6 when you reduce in lowest term is 1/3. End the story. This is the list. Let me know when you are doing this, but I am doing too fast. Yeah, I don't pay attention very much, too much. I select option B. Let me know that you have young people and see very well the thing. I select right or I select wrong. 1/6, 1/3, 1/3, 1/2, 2/3, 1 and 2. That's okay? I do it okay or not? Hey, answer me. Are you there? You pay attention. Okay, no good. No, okay. It's okay. Okay. I got it. I passed this class. I sort of understand. You can. The order is not important. Remember, this is a set. And the most important property for the set is, let me explain the property for the set. The order is not important. A, B, C is equal B, A, C. Or is equal C, B, A. So any permutation we can create. So, and the set, when you're talking about a mathematics about set, the order is not important. Another important, and the repetition is not necessary. Suppose the set ABC is equivalent to set A, comma B, comma C. Okay, therefore the repetition is not necessary. This is two important properties for the set. Well, not always is a set. Sometimes we have a right or arrange it. So in this case, the order is important. That is not equal 1 to 3 and 3 to 1 because this is 123. When the position is important, this is not set. Okay, guys? Okay, one more. This is easy. I understand very well this. This is no big deal for us. Minus 4x cubic, x cubic, no, x to the 4th power, plus 3x squared, minus 4x plus 6. My famous formula, plus or minus p divided by q. P is 6 and q is 4. I don't care the sign. The sign is not important because you consider them plus or minus. And you break it down. The factor of 6 I did before, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. It's 6, sorry. The factor of 4 is plus or minus 1, plus or minus 2, and plus or minus 4. Because 2 times 2 is 4. It's a coincidence. Now, the famous list is plus or minus 1. I organize in that way. You consider it 1 by 1, the number in the denominator. There are many ways to do that. You consider this divided by this, by this, by this, by this. So say plus or minus 2, because 1 is nice. Now it's 2. 2 is 1/2. 2 over 2 que es 1, que es the same. I don't want to repeat, of course. Plus or minus 3/2. And 6 divided by 2 is 3. I did that. So it's 3, no necessary repetition. Now 1 quarter, 1 over 4. When you're using 4, 2 4 que es 1/2. I did that. 3 4 no. 3 over 4. And 6 over 4 is 3/2, no? So 6 over 4 divided by 2 is 3/2. The 3/2 I have here. That's it. This is the list of the potential zero. Okay, I consider looking this choice I have. Okay, D plus or minus 1/4, plus or minus 1/2, plus or minus 2/3. No, 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 no. It's not D, no. You understand now? Okay, but I make a mistake here. It's not D, no? What is the option? Help me, guys. 2/3. It's A, no? 1/6. No, no, no. A, no. FB. Let me see FB. Yeah, FB. You're right. FB. Let me fix it in my paper. Okay, what is my pen? Where is my pen? Where is my pen? I have a lot of pen. Yeah, I never found the pen. Fortunately, I have here. FB. Okay, let's do one more. And that's it, because it's super easy to understand. 25. 25. Now. Okay, 25 is 5 x to the 5th power minus 6 x squared plus 6 x minus 1. This is P, this is Q. So the formula is plus or minus P divided by Q. And you put a P in the numerator, that's the only option. Okay, we have es 1, ¿no? Entonces es plus or minus 1. Entonces the only option que we have, the 5 is plus or minus 1 and plus or minus 5, no? Because 5 is prime number, no? Okay, entonces what is my famous list? My famous list is plus or minus 1, 1 divided by 1, comma, plus or minus 1/5. Entonces, what is the option que corresponde much better? I suppose que es option A, ¿no? Option A. Option A. Plus or minus 1 and plus or minus 1/5. Option. Any question, guys? Do you understand very well this or no? Okay, let's move on to the more complicated part. Yes, I understand. Okay, good. Okay, Yasmin. No, it's not Yasmin, it's Sean. I am confusing with you. You see the advantage and disadvantage of online class. I don't see the face of the students. When I see the face, I differentiate perfect Jasmine and Sean. It's obvious, right? Okay, let's go to 26. 26 is x to the 4th power plus 24 x to the 2nd power minus 25. Entonces, what they want? They want que using the rational zero theorem to find the real zero of the polynomial and using the zero factor to verification this. Okay. We can do it either way. Remember, in the real life, we're using the combination of factorization and scientific division. Okay? No always scientific division. No. In this case, it's obvious. It's elementary. By factorization, we can do that. X squared. And the combination is 25 and 1, no? Because 25 times 1 is 25, 25 minus 1 is 4. The sign are positive here and negative. And now I can focus it in the difference of a square because I know that this factor x squared plus 25 is prime in the real field. And the only possibility to break it down, this is in the complex field. Okay, by the way, this is curiosity. No, now this example is phi I and phi I, and positive and negative. But no, And the real field, we consider it like a quadratic irreducible expression. And this is prime. In other words, prime. We can now break it down. When it's minus, yes. When it's minus, yes. When it's minus, the famous difference of a square that you very well know. 1 plus or minus. End the story. So what is the answer? Well, the answer is they want you find the real zero. The real zero is obvious this and this, que es 1 and negative 1. This is the real zero. Entonces, well, the answer is 1, negative 1. And the factorization is this. This is my famous f of x function. F of x function. This is the factorization. I'll leave it like that. Don't touch that part in the real field. In the complete, yes, but in the real. Okay, sometimes, express the answer like a linear, no quadratic anymore. No, linear. So break it down. My famous polynomial in linear. Okay, entonces si es linear, this is xx, phi, I, negative, positive, negative. And the real part, no, stay the same. Okay, but this is not in this problem. Any question, guys? Confusing or clear? Clear. Yasmin say. All right. Let's move on to the 27. Okay, any problem? If you don't understand something, you can participate. This is your class. You pay for this, no? Okay, not only Yasmin Chan. Okay, 20 and Andreina. Okay, suppose x to the cubic plus 2 x squared minus 5 minus 6. Okay, ready to find the rationale. Okay, in my opinion, you immediately, don't waste the time, you put this polynomial in this. Entonces, en decimal, I can see, you can check it in the decimal if you want. We are doing 27 question now. I don't waste the time to switch into decimal now. You see, you have in your computer now, the question 27. I can see that the factor x minus 2 belong to this. I can see in decimals this. Just in case, okay, professor, I solving in decimal. No. Decimal is our tool que help me to understand the problem. But you need to prove me by hand que this is a factor. Okay, but this is easy, professor. 1, 2, negative 5, negative 6. And you divide by 2, no? Opposite sign. This is 1, bring down. This is 2. This is 4. This is 8. This is positive 3. And this is 6. Okay, exactly. Decimal, give me this information. I verify by hand. Therefore, the factor x minus 2 belongs to the polynomial. Super. Now, the rest, bueno, I see or I don't see in decimal, pero this is quadratic equation. X to the 0, x to the 1, x to the second. Wow, entonces x to the second plus 4x plus 3 is super easy factorization by hand. Okay, this is 2 parentheses, xx, 3 and 1, plus. So what is the final answer? The final answer is, well, the total factorization for this polynomial was x plus 1, x plus 2, and x plus 3. This is my equivalent f of x. And the 0 are negative 1, negative 2, negative 3, no? Let me see. Yeah, let me see. We are doing option 2. No, negative 2. Wait. It's positive 2, sorry. Negative But I make a mistake. This is minor, no? It's a minor. And negative 2, positive 1. Something is weird. It's negative 3, negative 3, negative 1, negative 1, and positive 2. Let me see. Is negative 3, negative 1, 2. And the factorization is x plus 3. Doesn't matter the order. X plus 1, x minus 2. Okay. Que es de option D, ¿no? ¿Es de option D? Es de option D, yeah. Es de option D. Any question, right? Sí, sí, lo compliqué. You get the idea or no? Sorry que I don't pay attention in that moment. It's okay or no? Can we go back to the 24? You are crazy. No. If you want, when the class is over, you stay with me. Yeah, I come back to the 24. No, hello. Come back to the 24. 3 problem before. No. Stay. You stay. I explain 24 for you. Okay? Okay, let's move on to the 28, no? 28 now, 28. 28 is 5 x cubed minus 24 x squared minus 9x plus 20. Okay, I got exactly the same procedure. I go to decimals and I can see that the factor x minus 5 below. I see graphically. Use my eyes. However, I want to verification algebraically or arithmetic using synthetic division. 5, negative 24, negative 9, 20. I put positive 5, bring down 5, 5 times 5, 25, and 1. The multiplication 1 times 5 is 5, is negative 4, and negative 20, good. By verification, arithmetically, get the factor x minus 5 belong to the polynomial. One way is one, okay, I can see also in decimals that the factor negative 1 belong to the polynomial. Let me verification. Bring down 5. 5 times 1 is negative 5. There's a 4, negative 4, of course. And it's a positive 4 is 0. Okay, super. This is the factor x plus 1 belong to the polynomial. And the last factor, que es linear, is x to the 0, is x to the 1, is the factor is 5x minus 4. Okay, entonces now, what's the factorization of this polynomial? Using a combination decimals and 2 synthetic division is x minus 5. The order is not important. X plus 1, 5x minus 4. This is my new f of x. It is equivalent to the original. And what about the factor? Well, the factor is 5. The 0, sorry, is 5. The 0 is negative 1. And the 0 is, you put it here, 5x minus 4 equal to 0. It's obvious que es 4/5. Okay? Entonces I try to find the solution, and I suppose que the best option que matching is A, no? Let me know, guys, si I do okay or no. Yes. So what's 28? 28? Let's do in 29. Wait, sorry, professor, where did you get? What do you get? What? For fifth? Sorry, I don't read. Send me again the messages in the chat or activate the microphone. What part you don't understand? Rene. Okay. Look. In the remaining part, 5x minus 4. This factor we can translate in algebraic expression like that. Because I suppose it's x to the 0 and x to the 1. Clear or confusing? Why did you pick -1? Okay, this is a good question. Okay. Let me show you. Let me switch into Desmos. Temporary. But wait, let me open Desmos. Switch into Desmos. Switch into Desmos. Okay, look. We are doing question 20 what? 28, no? 28. Okay, 28. Look at that. Boom. 28. Look at the graph of the polynomial 28. I can see clear, like water, que 5,0 es el 0. O sea, 5. En décimo ahí sí que de 0 es 5. De 0 es 0.8. 0.8, pero 0.8 es décima. I don't like perform scientific division using decimal. We can, of course, pero no. A -1. That is the reason I select positive 5 and -1 to perform scientific division. Do you see decimals or no? Sir? Sir, answer me. Do you see decimal, guy? Yes, okay. Do you understand now what is the reason I pick 5 and -1? Yes, entonces always we are doing that way. Don't waste the time. This in the other century, the engineer, scientific need to perform scientific division several times. Doesn't work. No. We save time with decimals. It's our fantastic graphic calculator. Okay, we come back to the whiteboard. At least you see clear in the decimals the rational 0. Irrational you don't see. Complex you don't see. But rational you see. Okay. So now let's move on 29. And you apply the same idea, right? 29 is the same idea. You put a graphic in decimals. You can see in the decimal I sent to you 2x cubic minus 3x squared plus 10x minus 15. Okay, because I can see in decimals. Let me see. 29, no? Let me go to decimals. 29. Oof, I got it. Look at that. Okay, let me switch into decimal to show you the idea. That not always is nice. Sometimes it's very, very hard and complicated to understand. That is the reason okay, we need to do several problems to understand. No? Okay, do you see decimals? Okay, we're focusing now in 29. 29, look. 29, yeah. Look at a line. 29, I copy the expression for the polynomial we're doing now. Yeah, I discovered, wow, we have only one real, que es 1.5. One positive real. You make it soon. We have no more. Only one. Okay. Let's move on to the whiteboard. And let's do scientific division using decimal. Unfortunately. Yeah. See, of course we can. Always, anytime. Even This is weird, but sometimes happen. Actually, I did. We can do scientific division even using complex number. Scientific division is amazing. Using decimal, you can. I want to show you now. Look. Okay, this is the format for the scientific division. Coefficients are 2, -3, 10, and -15. And the factor that we investigate is 1.5, no? 1.5, 1.5. 1.5, I can see in the graphic is positive. Therefore, the factor is negative, no? It's x minus 1.5. I want to modify a little bit. But okay. Entonces, bring down to 2 times 1.5 is 3. Oh, nice. 0. This is 0. This is 10. And 10 times 1.5 is 15. Super. With verification that the factor x minus 1.5 and stay alive. We continue. No, because we have no more. Real. 0. I suppose that the other 0, because in total we have 3 0 is imaginary. And the imaginary is coming by couple. So 2 imaginary. Entonces I copy x to the 0, x to the 1, x to the second. Entonces you can see que x to the 1 is missing, ¿no? Entonces es 2x squared plus 10. Okay. Let me modify a little bit this because I can see the great common factor here is 2. X squared plus 5. Y es obvio que x squared plus 5 is irreducible quadratic expression. And this factor, let me try to do something. This is x minus 3 half. Que 3 half is 1.5, ¿no? Entonces, si you put together this and this, I can multiplication by 2, this guy. Now you have 2x minus 3. Wow. Entonces, what is the factorization, professor? Well, the factorization of this polynomial is 1 real, que es the only real que I see in decimals, que es 2x minus 3, que, by the way, 1.5, and these 2 disappear because these 2 I put inside in order to eliminate the fraction and x squared plus 5. End the story. This is the factorization of our original polynomial. And the only real factor that we have in my hand is 1.5 or 3 half. Okay, 29, option B, no? Option B. Okay. Any question, guys? Sometimes happen when it's a fraction, to say after you need to manipulate. It's a classical example. Okay. Everyone follow me? Are you tired? You need break? No break. I follow. Okay, good. Let me try continue 30. Okay. Okay. 30 is 5 x to the 4th power minus 7 x to the cubed power plus 22 x squared minus 28 x plus 8. Okay, good. Okay, I put in decimals. Yeah, I discover something in decimals. Okay, let me try to switch into decimals. 20, no, it's 30. It's 30. Okay, 30 is this situation. Look, we discovered two real zero and one in 0.4. Okay, 0.4 is decimal or 2/5. You put in fraction either way. And the degree of this program is 4. So you suppose you have 4 zero in total, but you have 2 real positive, and the rest gets 2 more. I suppose it's complex because I don't see in this one. It's a ghost. Okay. Then we come back to the whiteboard. But I have some idea. I need to perform synthetic division using 1 and 0.4 or 2/5, whatever you want. Let's see what is the most convenient way of 5, -7, 22, -28, and 8. Let me start for the easiest one. Bring down 5, -2, -2 is 20. Multiplication by 1 is 20. Is -8. Is -0. Super. The factor x minus 1 belong to the polynomial. So now I see in decimal 0.4 or 2/5. Okay, 0.4, no? I don't know, but I prefer it that way. Bring down 5. When you multiply this and this, the 5 cancel and stay alive. Only 2. 0 is 0 is 20. And when you multiply 2/5 times 20, es obvio que es 6, ¿no? It's obvious, right? Therefore, the factor x minus 2/5 belong to the polynomial. Entonces sometimes happen que the one magical 5 happen here. Look at that. This is x to the 0 power. This is x to the 1 power. This is x to the second power. And the expression is 5x squared plus 20. Que le como factor 5. Es obvio que this guy is quadratic irreducible. So this apart the complex or the imaginary guys. And the factorization for our polynomial is, sorry, I don't matter. No, of course, no. The order is not important because it's a multiplication. 5 times 3 is equal to 3 times 5. It's a factor. Doesn't matter the order. Okay? The order is not important. Okay. Okay, good question. Okay, entonces I copy x minus 1, okay, but of this 5, we can multiplication times this. Actually, we have 5x minus 2, no? And stay alive, x squared plus 4, get the irreducible quadratic. Entonces somehow, the factor involved in the problem was the real, no? It's 1 and 2/5 que we found in decimal, no? 0.4. Entonces, what option you select? I suppose que you select option C, correct? Correct or incorrect? Good. Good. Okay. 30, 30, 34, 34. Okay. Okay. Let's do a number 31. 31. 31, I don't do in my piece of paper. But it's okay. Let's do it. 31. 31. 31. 31 is x cubed plus ax squared plus 19 x plus 12, no? Okay, in this case, no function, it's equation. And they want you to find zero, no factorization. So the answer is x equals something, x equals something, x equals something. Entonces this is relatively easy because I immediately I go to Desmos. Okay, wow. Okay, let me switch into Desmos. One more time. I type in. Yeah, I discovered, wow, look at that. I discovered the zero. I discovered the zero. The zero is -4, -3, and -1. Okay. Let's do a scientific division at least 2 times because the degree of the polynomial is 3. When you perform the scientific division the first time, so let me copy in one piece of paper because I need to remember, and the 31st is -1, -3, and -4. It's the option C, right? But I need to prove by hand, perform synthetic division 2 times, right? Let's do it quickly. Okay, let's do it quickly. Okay. Okay, I have no idea what factor I want to start. But I try to start for the easy, que es -1, ¿no? Es -1. 1, -1 is 7. And -7 is 12. And -12, 0. I verify que x plus 1 is a factor that belongs to this. What is the other guy? -3. Okay, let's do a -3. Okay, in this moment, we have a quadratic. Well, another possibility is factorization, que is super easy. Look at that. This is x to the 0, this is x to the 1, and this is x to the second. This trinomial is x squared plus 7x plus 12. Okay, when you perform the factorization, is xx 4 and 3, because 4 times 3 is 12, 4 minus plus 3 is 7, plus plus. And this is the factorization. So the f of x factorization is x plus 1, x plus 4, x plus 3. And the zero, the thing they try to ask me in this question is -4, comma, -1, and -3. Wow, I suppose I put too much example in the review. Okay, you consider that you understand the thing and you don't need to repeat again the same idea or no? Yes or no? You let me know. You are my customer. Do you understand que one more? Okay, okay, super. One more. Andreina proposed me good solution. Okay, one more. Okay, let's do it in 32, for example. 32, 32, 31, 32. 32. 32, 32. Just in case, remember, I sent to you the decimal, no? Okay, maybe save time. Let's do it in 32. 32. 32 is x cubic plus 5 x squared minus 12 x plus 14. Okay, 32, 32. Entonces I discover en decimos. A ver, 32. 32. Okay, okay, let's go to decimos to see the graph of this polynomial. 32. Wow, what the hell? Look at that. Let me switch. Do you see? This is the graph 32. It's very, very weird. Yeah, very, very weird. Look at that. This is a polynomial. Wow. But we have only 1 0. Okay, by the way, is you click on the curve, or no, specifically on the point, okay, you believe is negative 7. That the only real zero that we have is negative 7. Therefore, the answer is D, no? Okay, but just in case, one question like that, you say, no, I do it in Desmo. No. Desmo is my auxiliar, like a calculator. Okay, but you need to show me the word in detail. So say you perform the synthetic division. I come back to the whiteboard. Okay, yeah, I know the negative 7 is a good guy, a zero, a real zero. 1, 5, negative 12, 14. And you divide by negative 7. In the graph, you see negative 7. You put exactly the same. The only case different is the factor, que is x plus 7. Bring down 1. Multiplication is negative 7. Is negative 2. Multiplication is 14 positive. Is 2. And 2 times negative 7 is negative 14. Okay, you prove here with synthetic division que the factor x plus 3 plus 7 belong to it. Okay, the rest is x to the 0, x to the 1, and x to the second. And the problem says investigate the real. And the decimal, I see only one real. But I don't understand very well why, professor. Huh? Because I suppose that this quadratic equation, the solution is complex. So there's one easy way to determine that this is complex is using discriminant, not necessarily quadratic equation. Well, you solve it, but one part. Si discriminant is positive, es real. Si the discriminant es 0, es real, pero 2 real, 1 real. Si the discriminant es negative, es complex. Entonces, en our problem, A es 1, B es negative 2, and C is positive 2. Entonces, when you compute the discriminant, es negative 2 squared minus 4 multiplication by 1 multiplication by 2. Dice 4 minus 8 es negative 4. Es negative, es complex. Okay, entonces the only guy que es solution, que es real, es negative 7. Like the option D. Option D. Any question, que es this answer? Option D. Good, very good, or very bad? Okay, we finish. Ajá. Entonces, no more, ¿eh? It's a little bit boring, ¿eh? It's a little bit boring. Yeah? Andreina is good. Okay. Andreina feel good. Okay. Now let's move on to the problem 41, 42, 43, 44, 45, 46, 47. Okay, 41, 42, and 43 is the same. It's a little bit weird. I never explained that in the lecture. But it's no big deal. It's super easy. Let me explain in super detail this idea, que is a little bit complicated. No? Normally in my lecture, I avoid this. However, in the review, I include this idea. It's bounded. So you need to find the bound of the real zero of the polynomial. Suppose, what is the idea? What is the idea? The idea is, suppose we have polynomial. Like that. And we have 1, 0, 2, 3, 4 and 5, real 0. Not necessarily degree of 5, because maybe you have complex, right? There's one procedure to determine the bound. So we have two bounds. We have upper bound and lower bound. What means that? When you try one by one, for example, suppose 1, suppose 2, suppose 3. And I suppose that 3 is the upper bound, because every 0, boom, 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 is smaller than 3. This is 3. And likewise, in the negative part, you try -1, -2, -3. In this case, it's a coincidence. The lower bound is -3. This is the idea for the bound, upper and lower. So how you determine this? There are many ways to do that. So I want to explain using synthetic division. Okay, for example to determine, I want to explain the shortcut to do fast and no is approximation, no? Because bound is approximation, no exact. Suppose this example: 2x cubic plus 5. This is completely out the problem. Another illustrative example that I create for you. So you have no idea, because suppose we have in the jungle without decimals. Okay, 2, 5, -8, -7, and you perform synthetic division using 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 100. Okay. So bring down to, I want to do fast, guy. This is 2, this is 7, this is 7, this is -1, and this is -8. So now you see in the last row, you see positive and negative guys. That means that this is not the upper bound. Suppose N2. Bring down 2, do that to 4, and 9, is 18, is 10, is 20, is 13. So when you discover that everything in the last row is positive, that means that we discover upper bound. The upper bound is 2. Okay, our 0 is in between 2 and the upper, and the lower I have no idea. And the lower I try the negative guy. So I am doing synthetic division several times using -1, 2, 5, -8, -7. I repeat the problem several times. Okay, so es 2, es -2, es 3, es -3, es -11, and this is 20. -11, es 22, no? 22, positive 22 is 15. And you see that some guy is positive, another is negative. This is not lower bound. And we continue, bam, 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 bam. I don't want to, -2 doesn't work. It's positive and negative. -3 is positive and negative. However, -4, surprise, happen, new situation. Look, bring down to this is -8, this is -3, this is 12, this is 4, and this is -16, and this is -23. Oh, when you see when you see that situation in which you have the sign alternating, positive, negative, negative, positive, positive, negative, that means that this is a lower bound. It's negative 4. So I guarantee that the zero of this polynomial is in between negative 4 and 2. And it's the interval in which you have to investigate the zero. Suppose that we have no calculator. We have no decimals. We have no graphical calculator. However, this is too long process. It's a disadvantage. You know, in the life we have different possibility, and you need to evaluate advantage and disadvantage. And we have some book apply one estimator. Estimator. And the formula for the estimator is a little bit complicated, but I can try to explain in one easy way. Look, you take again the original polynomial. Guess this. Okay, the formula for the upper bound, so the estimator supposed to get the same. Equal m. And you take the maximum of the coefficients. Es obvio que the maximum is 8, no? And you divide by the leading coefficients, que always is 2. So a sub m. Of course, absolute value, guy. I don't care if it's positive or negative. You take positive 8 divided by 2, que is the first coefficient, plus 1. Plus 1. Plus 1. 8 divided by 2 is 4. Plus 1 is 5. So you suppose que the zero living in between 5 and negative 5. You suppose always the same. Okay, actually it's not exactly the same. We prove with the long method, no? But it's estimator. So do have some roughly idea in between what value lie. So this is the idea for the problem 41, 42, and 43. Yeah, I know que it's the estimator because it's the same number, 6, negative 5, 16, 9. Okay, let's do it at least one. At least one. And you have idea, no? Suppose 41. 41 is x to the 4th power plus 2 x to the 2nd power minus 3. The formula for the capital M, you take the higher exponent, get 3, divided by the leading coefficient, get 1 plus 1, is 4. So you can affirm that the interval in which lie the zero is in between negative 4 and positive 4. Do you understand the idea? Do you understand the idea? Yes or no? And 42 and 43 is exactly the same. And you can see in this one, the guy do the graph exactly of this. Do you understand the idea? Or it's confusing? Understand or confusing? Confusing. Okay, it's just a stupid formula. And that's it. You find the maximum coefficient divided by leading coefficients plus 1. And you determine one number. And you suppose, hypothetically, que the zero lie in between this interval. What part confusing? One more. Okay, Andreina, one more. Okay, I promise in the test I don't put this, right? But one, no. Okay, one more. 42. 42. 42. Okay, 42. 42 is 4x to the 4, x to the 4th power plus 3 x to the... Let me do 43, because 43 is more illustrative of the idea. 43 is more clear. Everything is possible, no? But 43 is more clear. Is x to the fifth power minus 2x to the fourth power plus 2x to the cubed power. Let me see, I do it okay? Yeah. Minus 8 x to the second power plus x minus 2. Okay, the formula for the capital M is you take the absolute value coefficient, the greatest absolute value. That's all we can say. I don't care que es positive or negative. Divided by leading coefficient, que es 1, plus 1. Entonces, this is 8 plus 1 is 9. Entonces, I suppose que the interval is in between negative 9. O sea, negative 9 and positive 9. Like the option B, no? This is a stupid question for me. I want to illustrate one possibility of algebra. But in the test, I never put this example, this question. No. This is crazy. Okay, thank you. Okay, let's move on to the 44, 45, 46, and 47. It's the same thing. This is mandatory. Suppose in the test I put something like that. It's mandatory using decimal. Oh, graphic calculator. Let me show you in detail at least one. It's super easy. Super easy. Super easy. Let's do it 44. 44, I want to find, this is, the equation has solution R in the interval indicated. Approximate this solution correct into decimal place. Okay. So x cubed minus ax minus 3 plus 3, no? Minus 3 equals 0. So the information is given equals 0. It's a polynomial equation. The information gets given is minus 3 less than R less than negative 2. So I want to investigate what's going on inside this interval. See, first of all, we have 0 or no in this interval. And secondly, what value with the approximation to decimal place. Entonces, the only possibility to do that is using graphical calculator. Of course, we go to decimal. You put equation 44. But I want to show you one important detail. 44. I did 44 and 45. Because by curiosity, 44 and 45 is the same equation. But okay, don't worry. Let's do it one by one. Look. I switch into decimals. Because the only possibility to do this is graphically. Look. Look. Do you see decimals? Okay, forget about that part. Temporary. Let me put it in the projection mode to see much better. Okay. Okay, I copy my polynomial. Look at that. I copy. Do you see decimal? Yes or no? Good. Now I copy my polynomial. Y I enforce que I want to see the graph only. We don't see decimal. Why? We don't? Everyone? No, Andreina. Okay. Okay, don't worry. I try. Again. No, okay. I understand. Now? No? Okay. Sometimes happen that situation. When that happen that situation, entonces I reset. Stop sharing, not sharing anymore. Yeah, I sharing now with the decimals. I suppose this is decimal, yeah. Now, yes, okay. Sometimes happen I try to switch in from one window to another window and doesn't work. However, when you reset the share, not share anymore. Okay. What is the idea? Focusing on mathematical part. I copy my polynomial on the question 44 and 45. I copy, I put this curly bracket. This curly bracket indicate me that I want to see the graph specifically only in this interval. And you see one part of the polynomial, one piece, one segment, one curve. Well, it's an arc. Now, I go to the potential zero, que es this guy, and the answer is negative 2.618, que I suppose, using my common sense, que corresponde with the option C, because the option C is negative 2.62. They want to round to the 2 decimal place. Clear or confusing? Clear. Likewise, let me activate this, que es the question 45, and desactivate this. It's the same polynomial, but different interval. Yeah, I make a zoom, y I suppose que es this, the zero, que es negative 0.382. Negative 0.382, and when you round, you truncate the 2, because it's less than 5. No, it's less than 5, yeah. Therefore, it's negative 0.32, it's 38, que es the option D. Any question? Any question? Piece of cake or piece of rock? Super easy. I like this. Okay, I suppose, well, we try. Si we don't finish today the review, don't worry, because we continue a little bit next time. Just in case, when the time is over, okay, finish at 11 o'clock because I have another class. I want to send the test, no? And you start working on the test. Maybe extending a little bit the due date, no? No es March 2nd, es March 4th. O sea, no next Tuesday, es next Thursday. Okay? This is not important. This is no big deal. This is not our problem. Our problem is that you understand very well everything. Okay, clear or confusing? Likewise or similarly, 46 and 47. Do you want to explain or no? 46 and 47. Yes. Okay. So, you know, this kind of problem, Sean, it's impossible. Do it by hand. And the only possibility we have is using the calculator. Okay? Entonces ahí typing the, okay, entonces ahí typing the polynomial, que es x to the 4th power minus x to the 3rd power minus 7, x to the 2nd power plus 5, x plus 10, y hay specification the interval I want to investigate. And the first one is minus 3 from negative 3 to positive to negative 2, sorry, from negative 3 to negative 2. And the second is from positive 2 to positive 3. Okay, let's do it one by one. Let's focus on the red part. And the red part, the zero is, boom, negative 2.236. To say you round is negative 2.24. That's the option C. We are doing 46. Do you follow me? Any question? Now, in the other part, gets the same. Well, then we make it zoom to understand much better. Well, actually, is in between 2 and 3, but no include 2. So we have 1 0 and 2. Look, but this 0 no, because the interval do not include 2 and include 3. So the 0 that we are looking for is this, que es 2.236, que es 2.24 positive, que es the option D. Any question? Any question? No? Yes or no? We just have to use in this one. Right. Yeah. In this case, definitely. And I want to illustrate the complexity of the solution for the polynomial. It's very, very complicated. It's very okay. The example, the academic example, I try to bring easy example, but not always it's easy. No. Not always it's easy. Okay. So you understand very well this. Let's move on to problem 48. 48. Let me switch into the whiteboard. Okay, there you go. You see the whiteboard? Oh, whiteboard. Okay, good. We are doing now 48. Okay, 48 is from the polynomial f of x with real coefficients having the given degree and 0. Okay. The information is given is degree. Degree of this polynomial is 3. And it's giving some zeros. The 0 are -2 and 3 plus I. Bueno, so what is the answer? Find the equation of the f of x. I need to find f of x to satisfy this requirement. Okay, degree 3. So I suppose we have three factors. One factor is real, is -2, and another factor is complex, que es 3 plus I. But I know, you need to know, que the complex is coming by pair of conjugates. The other is 3 minus I. This is the conjugate of this. Remember, conjugate is the same complex number, but opposite sign in the imaginary part. Okay? And this together, this together, 3 factor, correspond perfectly with the equation for the polynomial. So I propose one shortcut to do fast and efficiency. You multiply. Okay, remember the factor normally have that format: x minus c. And c is -2, for example, double minus become positive. Entonces c maybe es real or no, o es complex. Es real or complex. Entonces I propose first, always. It doesn't matter the order, pero es more elegant and easier, in my opinion, do it in that way. You multiplication first, the complex. O sea, entonces you open one first factor, que I put a bracket. Do you understand why I put a bracket? You put x minus, and you put z, que c is 3 plus I. And the other guys is parenthesis 3 minus I. I put a bracket because I'm using the outermost grouping symbol, no? And I put a parenthesis mandatory because this minus affect everything inside this factor. Entonces, es magically, because when you are doing the multiplication, this, que es a complex, the answer is not complex. The answer is real. So you select, for example, the real and one complex, the answer is complicated. Okay, entonces I highly recommend FOIL now, x times x is x squared. This time this is minus 3 minus I x. This time this is minus 3 plus I x. And this time this is last is plus, because minus and minus positive is 3 plus I times 3 minus I. Let me try to do that part first, because I remember something in college algebra. When you multiply any complex number times its conjugate, the answer is real. And I don't know if you remember, there are a shortcut to do fast this. Because you multiply 3 times 3 gets 9, and 1 gets the coefficient here, and 1 is 1, and you add it. And the answer is 10. So you don't remember the shortcut, no problema. Because you multiply exactly the same like a kindergarten guy. You foil. This is a binomial, and you multiply 3 times 3 gets 9, and you multiply this and this is minus 3i, and you multiply this and this is plus 3i, and you multiply this and this is minus I squared, and always happen two situations. Situation number one, the imaginary part is gone, always. When you multiply any complex number times its conjugate, and I stay the same, but negative I squared, you know, okay, I squared is negative 1, and this negative 1 and this negative 1 is positive 1. Always is positive, always is positive. That is the reason I apply the shortcut directly. And the answer is 10. Therefore, the thing we have so far is x squared. I take advantage and remove this parenthesis. Is minus 3x plus ix, negative positive, minus 3x minus ix plus 10. Entonces now look, I like that. The imaginary parts cancel. Always happen when you are doing in this order. We have x squared minus 6x plus 10. And what this was the second degree polynomial that we obtained after the multiplication. The first two 0, one gets given, one gets not given, but you suppose you know que es a conjugate. And when you multiply two factors that involve complex and they are conjugate, as always, because they are coming by pair of conjugate, you get real. And the rest is okay. The rest is multiplication, x plus 2, and x squared minus 6, x plus 10. Okay, apply FOIL in the story. Let me explain one easy way to do that. You multiplication, for example, x times x is x cubed. And you multiply this times this times this is minus 6 x squared plus 10x, no? Now basically you multiply x times this. And you multiply this times this times this. And you put it not exactly at the continuation. You put it in below, a little bit below, and align with the corresponding degree, no? You copy, this is 2x squared, you put 2x squared here. Entonces you put 12, no? It's 2 times 6, negative 12x. And you put 20, no? 20. It's a one, comfortable way to express this. And we combine like that, by column, taka. It's cubed minus 4x squared minus 2x plus 20. Que corresponde perfectly with the option A in Awanda. Wow, I like this problem. For sure, I put something like that in the test. Do you understand very well or very, very confusing? Very, very well or very, very confusing? Confusing. Okay, Sean, I understand. I understand very well. Okay, let's do more. No problem. We have time. It takes what? Take what? Repeat again your idea in the chat. I don't see the last message. Or activate the microphone to talk to me. The question take so. No. The question is that you need to find the polynomial equation that satisfies this condition. Degree 2, look at that. Degree 2 is the higher exponent. And contains 0, negative 2. The zeros -2 and triple side. Default, you understand very well that the second one is 3 minus I. It's 3 minus I. Therefore, I start the process of the multiplication. Okay, guys. I propose you stop. However, I want to send now the test, and you please let me know if you receive or not the test. And see you receive, you can leave. Now, please remember the thing change is que next Tuesday, well, in the first minute of our lecture, we finish the review package, and of course we start new chapter 3. Okay, it's very, very interesting and complicated, chapter 3. I got it. Say goodbye. So you gotta say goodbye. Tuesday, we continue the last piece of the review package, and we start new chapter. And you can working now directly in the test, no? But the due date I changed a little bit. No, it's March 2nd, it's March 4th. Super. Guys, bye-bye. I am leaving. Bye.